So this video lesson is all about solving two-step equations where we have variables on only one side of the equation. Now, depending on the types of equations we're looking at, we may get into 3 operations that we need to do, a few different other steps to make the equation easier to solve, but the essential part is we're going to have variables on one side of the equation, and there's going to be more than one operation that we're going to need to do to solve it. So in order to talk about these two-step equations, the first thing we need to do is we need to go back and look at equation solving as we've done it so far. And that includes equations like x minus 3 equals 7 and negative 5 times x equals negative 20. In both of these cases, we have only one operation that is being wrapped up with the x. On the left-hand equation, we have an x minus 3. That operation is minus 3. 3 is being taken away. So to keep the equation in balance while also isolating the x, we're going to use the inverse of that operation and create the solution for the equation of x equals 10. And notice, again, the most important part that we have is that we are showing that we're adding 3 to both sides so that we maintain the balance in that equation, so that both sides we're showing really do still equal each other. On the right-hand side, where we have negative 5 times x, we're going to divide by negative 5 and end up with x equals 4. Again, showing that we're keeping the equation in balance by dividing on both sides, using the inverse operation of the things that are happening around x to essentially unwrap x from all of those different operations and leave it isolated on one side. Now, obviously, not every equation that we are going to need to potentially deal with is going to have only one operation. We can add a few more to it and end up with what is sort of the next level of equation solving, which is what happens when we have two operations mixed up. Here, 3x plus 1 is equal to 16. So I'm going to ask you to go ahead, pause the video, just play around with this using the skills that we have so far for equation solving. See what you can do to move from 3x plus 1 down to just a situation where we have x. Come back when you are ready to see some ideas, get some processes, and move on. So what we notice here with this equation is that there are two things that we're going to have to deal with. We have a 3 being multiplied by x that eventually we're going to have to use division to take care of. We also have a plus 1, an addition, that we're eventually going to need to use subtraction to take care of. And really, it's up to us which operation we do first. As you'll see from this example, there are going to be ones that are significantly easier, and that I always recommend that you do these types of operations first before you do the other. But really, as long as our processes are correct, we can start with either. So we have the option of either dividing first or subtracting first. So let's take a look at what both of those would potentially mean. When we subtract first, we start with 3x plus 1 is equal to 16. Subtract 1 from both sides first to end up with 3x equals 15, because 16 minus 1 is 15. Then divide by 3 to end up with a solution of x equals 5. Now, if we do all of our work correctly on the second style of solving, and if we've done all of our work correctly, which, spoiler alert, we have, on the first style of solving, we should also end up with the solution for x equals 5. So now let's take a look at 3x plus 1 equals 16 when we divide first. Now remember that multiplication, division, addition, and subtraction are all operations that happen to a side of an equation. And so to divide a side of an equation is not to divide a single term by 3, but to divide the entire thing by 3. Where we can add and subtract only specific terms on each side is because addition is commutative around with itself. We can move addition around, we can subtract from a particular term, even though we are technically subtracting from an entire side. Multiplication and division, though, have to go across every term on every side. So 3x divided by 3 is x, but 1 divided by 3 is 1/3. And 16 divided by 3 is 16/3, or 5 1/3. Now, when we subtract away that 1/3 on both sides, we end up with x equals 5. So again, we will end up at the exact same solution, but by dividing first, we open ourselves up to the possibility that we're going to have these slightly more complicated issues of having to deal with fractions. Now, there's nothing wrong with dealing with fractions. Fractions are perfectly good numbers. Decimals are perfectly good numbers to deal with, but there are potentially, depending on what the equation is, ways to avoid using fractions until we absolutely have to at some point. Whereas if you divide first in particular, you open yourself up to the fact that we may not have whole numbers or easy fractions to deal with. They both end up at the correct solution. One way tends to be a little bit more straightforward, and that's by adding and subtracting first. And we can see that because in another way, because our two goals for solving our equation are to keep the equation in balance and to isolate the variable. And when we subtract first, the first thing we do is move everything so that the only thing left on the left side is the variable term. Not just the variable itself, but the variable term. And then we can divide by 3 to end up at our solution. So the key things are you have the choice of what operation to undo first. That is up to you. If you want to undo multiplication first, that's great. You can use division. If you want to undo addition first, that's great. You can use subtraction first. But just remember, when you're multiplying or dividing both sides of an equation by something, it is the entire side, not just a single term, but the entire side that is being affected by that operation. And so my recommendation is that when in doubt, add or subtract before you multiply or divide. So I'm going to ask you to go ahead and pause the video and write down these two important steps, or these two important ideas with solving equations that have more than one step in them. We'll go back to the next page so you can write down that advice too. We'll see an example problem or two, and then we'll give you some practice problems for you to do on your own. So go ahead, pause the video, write these down, come back when you're ready to see the next one. All right, one more thing to write down. Again, just a piece of advice, but when in doubt, add or subtract before you multiply or divide. It will make your equation solving that much simpler in general. This will work for 90% of equations that you see. Some, it is actually easier to multiply or divide first, but we'll see those in a little bit. All right, let's take a look at one more type of problem that we might see. Here with two different operations that we haven't seen before. Actually, we'll look at two more. X over 7 minus 2 is equal to negative 1. Again, we have our choice of what to do. Let's follow the advice of adding or subtracting before we multiply or divide. X over 7 is equal to 1 because negative 1 plus 2 is equal to 1. And then multiply both sides by 7 to end up with X is equal to 7. Now, if we multiply both sides by 7 first, we still end up with a correct equation. Multiplying by 7 on both sides ends up with x minus 14 is equal to negative 7. And when we add 14 to both sides, we do end up with x equals 7, just like we did if we added, yes, in this case added rather than subtracted first. But that will not always be the case. And in fact, the times when it is easier, potentially, than division is when we're multiplying on both sides. One more example. Here we have 5 plus 2x is equal to negative 7. Let's start with addition or subtraction. We're going to subtract 5 from both sides because we want to leave that 2x off on its own. Negative 7 minus 5 is negative 12. And then when we divide both sides by 2, we end up with a solution we want of x equals negative 6. All right, time for you to work on some problems on your own. 3 pages, 2 problems each. Go ahead, pause the video, see what you can do here. We might need to do some other things like distribute or combine like terms before we end up with a solution. But pause the video, work on these, come back when you are ready to see the answers. Now on the left-hand side, we're going to subtract 3 from both sides first. That'll give us negative 4x is equal to 8. And then we'll divide by negative 4 to end up with x equals negative 2. On the right-hand side, we're going to distribute first. We can divide first, but let's look at it if we distribute first. Plus 12, subtract 6 on both sides to end up with 3x is equal to 6, and divide by 3 to get x is equal to 2. Now, if we decided to divide first, and we divided both sides by 3, well, then we would just end up with x plus 2 equals 4 and subtract 2. But we have to be careful in this case because we have to divide an entire side by 3. In this case, it just so happens that x plus 2 is multiplied by 3. And so there are always slightly different processes we can use. But if you're not sure whether or not you're dividing properly across an entire side or if you're multiplying properly across an entire side, you can always go through the operations that you see, distribute the 3 to make it 3x plus 6, and then follow those processes we've seen before. It may take a few more steps potentially, but it may also feel a little bit more straightforward to get to the answer that we're looking for. 2 more problems for you, second page out of 3. Go ahead, pause the video, see what you can do with these. Come back when you're ready to move on. On the left-hand side, we're going to start by adding 1 to both sides. That's going to give us negative 7x is equal to 7. Then we're going to divide by negative 7. Notice we're dividing, not adding, because that's not addition on the left-hand side. That's multiplication. 7 divided by negative 7 is negative 1. On the right-hand side, let's add 3 to both sides first. Get x divided by negative 2 is equal to 4. And then we multiply by negative 2 on both sides, and we end up with x is equal to negative 8. Last page of problems for you. Go ahead, pause the video, see what you can do here. On the left-hand one, remember, well, we've never seen anything like this before, but our goal is to end up with a single x term so that we can either multiply or divide or end up with an x equals something. So what can we do on the equation on the left side so that we end up with only a single x term that we need to deal with? So pause the video, work on these problems, and come back when you are ready to see the answers. So the first thing we need to do on the left-hand side, you might have tried to divide by 2, divide by 3, divide by negative 4. Lots of x terms always present a problem to us when it comes to multiplication or division. So we're going to combine all of those x terms into a single x term. And this is going to be incredibly important when we get to the point of variables on both sides. But 2x plus 3x is 5x, and 5x minus 4x is just x. So here, 1x equals 9. We can solve it simply by combining all the like terms. On the right-hand side, we're going to add 9 to both sides. That's going to give us x over 5 is equal to 0. And then when we multiply by 5, we end up with x equals 0. So a real quick review, solving equations where we have multiple steps uses the exact same processes that we do to solve equations that have single steps. And the 2 important things that we need to remember about it are A, that we always have the choice of which operations we want to undo first. We cannot steal operations from inside parentheses or from inside exponents or something like that. We may have to distribute first. We may have to combine like terms first. There are some things that we just have to do. In that example of 3 times x plus 2, we could not have subtracted 2 from both sides first because there was the parentheses there. But when there are no parentheses or complicated things like that, you have the choice. That being said, multiplication and division operate on an entire side, not just a single term. So when in doubt, after you distribute or combine like terms, add or subtract before you multiply or divide.